What's up, y'all? Welcome back. We're still in fractions. We're still that's not what it's saying, so I should say that. We're still talking about some fractions here, but today we are gonna just go ahead and kind of look at everything we've done so far and make sense of maybe some of the patterns that we see when we're dividing fractions, right? Because we are talking about quotients. So again, like what are some of the patterns we see when dividing fractions to help us? And here's where we're going with it, help us with what we can call reasonability. 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 So again, helping us just again continuously make sense of things that are going on in our world of math and fractions and whatnot. So we're gonna kind of dive into some algorithms, and I'm gonna walk through a couple problems. And then kind of step back and say, like, what are we noticing with some patterns we see? So let's start here. In the beginning, we were talking about this concept of a whole number being divided by a fraction. So, like, maybe I have something in like four and I'm dividing it by 1/3, right? So, when we were talking about this, like, one, there's a way that we can solve this, right? We think about always with our expression, and that's what we're looking at here. This is an expression, right? Numbers, operations, no equal signs, no answers. When we get into that, we're really thinking about that first number in your expression is what we're starting with. And this is what we're starting with. We're literally starting with a 4. And it's holes, it's 4 holes. So what we can do is we can model that, right? So again, review, here's what we start with. We got 4 holes. And according then to this work here, what we're doing is we're taking these 4 holes and we're splitting them up into groups of 1/3 sizes, right? So that really does just mean that each hole is being cut into 3 parts. Because if I was to do that, again, we can see that this right here is 1/3. This is 1/3. This is 1/3, right? And so that's what we did there. But we are also doing this for the entire thing. So that's 1 hole, and then 2 holes, and then 3 holes, and then 4 holes. So when we put all of that together, right, that's what we're looking at. Is the question is then how many 1/3 size pieces do we get out of the 4 holes? Well, we can see here that I get 3 pieces here, and I get 3 pieces from here, and I get 3 pieces from here, and 3 pieces from here. So I really do end up with 3, 6, 9, 12 pieces or 12 holes. And I guess that's maybe not really what the answer. The answer isn't really saying I have 12 holes, because as you can see from the model, we don't have 12 uh full squares that I did in the black color, right? There aren't 12 of those. But what there are is there's 12 1/3 size pieces, right? So that's the work that happens there. We get a whole number, we run into this, we move on. Let's try another one, right? Let's take another whole number. Let's see, this time maybe we'll do like an 8. Um, 8 holes, and let's divide that by, oh, I don't know. Let's do what did I do last time? Oh, 1/3. Let's do 1/4, right? Okay, so again, some pieces that come out of this. One, we're starting in our expression with the holes. So that's what we want to do. So let's just start with holes. And I have 8 of them. So I can have 1, 2, 3, 4, 5. Oh, you know what? This seems like a lot. I'm going to change this up. And this is something we've talked about, right? Mixing it up. You know what? Instead of going with 8 holes, I'm actually going to take 8. I'm going to show it on a number line. So I'm going to go number line. I'm going to go 8. There's 0. Let's see. In the middle would be 4. That'd be a 6, and then a 2, and a 3, and a 1, and a 5, and a 7. And so when we think about it this way, right, the same idea, what's happening here is each hole, which we can see on the number line, is literally being cut into 4 pieces. So like this hole right here just got cut into 4 pieces. This hole right here is getting cut into 4 pieces. this hole right here, right, which one could argue is like technically the number 2, it's also being cut into 4 pieces. So what we're noticing is that for every whole number, we're getting 4 pieces that are the size of 1/4. Excuse me. Dang. Sorry, I'm having a hard time breathing. Okay, I'm fine. Don't worry. This isn't like a panic moment. Okay, so with 4 pieces per hole, well, if I have 4 here, 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 and 4 here, then really we are, these are 4s, by the way. They started to look like weird shapes. We are technically thinking that 4 parts per 8 holes equals then 32 pieces that are the size of 1/4. Okay. And so that's the realm we're in. So just noticing those right there. So there's 2 problems on that. Now let's kind of go into this next piece. And that's when we start talking about, well, what happens then when we go the other way around? And I'm gonna go ahead and what was our first example actually? We did 4 divided by 1/3. Let's say, for example, then we take 1/3 and we decide to divide it by 4, right? So what's starting to happen here, right? What's the result of the events that are about to occur is, again, with this expression, we got to think about what we're starting with, and what we're starting with is 1/3. So I actually get to model that idea again of 1/3. So that's less than 1 hole. So I only need 1 rectangle. And then again, it's 1/3. So I'm only shading in 1/3. So this is literally the only part that I'm working with. It's only this 1/3. It's the part that's shaded in kind of this like tannish yellowish color. That's all I have. So we're taking this 1/4, or excuse me, 1/3, and we are going to then cut it into 4 pieces, which means it's easier if I kind of go this way. Like I could go horizontal again, but I love the ideas of rows and columns. They help me see it. And so then when we look at the process of this, we have to remember that we're actually taking this 1/3, right? This color here. I'm gonna like, maybe I'll go over it with this color so it matches the shading. This color here, this 1/3, has been cut into 4 pieces. And if we look at that, we have to think about what is each one of those pieces now. And we have to look at it as a whole. So I do see when I look here, we never got more, right? We never got more than a whole. So this is going to be a fraction. That is for sure. So this is going to be a fraction. So I know here it's a fraction. If I look at it, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. But then again, we are thinking about what is one of these pieces. That's the work that we're doing here. It's like, what is the one of these 4 pieces? And we can see there, and I mean 4 by the shaded ones, by the way. We can see there's 12 total, but actually one of these is just 1/12, right? One of the shaded pieces is 1/12. So when we take 1/3 and we divide it by 4, we end up with 1/12. Okay. And that's the work again, when we have a fraction first, what do we do? Which is different than when we have a whole number first, what do we do? Right? Like, again, these are all the different bits and pieces that occur with how we take care of our business. Right? What are the different steps with the different skills? So let's do another one. And again, I'm actually going to go back to what we did in this one. We said 8 divided by 1/4. So let's change that around. What if we went the other way around? And what if we said, or is that what? No. Yeah, 8 divided by 1/4. What if we did that? What if here we actually said, okay, cool. Let's take 1/4 this time, and let's divide that 1/4 by the 8. Let's go the other way around. Divided by 8. Okay. And that's exactly what then I want to be thinking about putting together is I'm going to go ahead and say to myself, all right, well, according to this expression, I have 1/4 first, right? That's what I'm starting with. So I'm going to draw a model. I have 1/4 only. So I only have this red shaded area. That's all I possess. I have less than 1, right? You could even think about it as like This is a pizza. The pizza was cut into 4 slices, and I only have 1 slice left. I have 1/4 left. Now, with that 1/4 slice, well, gosh, 8 people are staring at it, and they're like, oh my gosh, we're going to eat this. And then you're like, okay, well, let's share it because we're really good people. So we're going to take that 1/4, we're going to cut it into those 8 pieces to share with people, which means we're going to get a pretty small bit of that pizza. So there's the 8. So what we're gonna then focus on to make sense of this, right? Again, is we're getting down to this little piece right here, this one of these little pieces. And we know already this is way less than 1. So this is gonna be a fraction. And if I had 4 columns and 8 rows, that tells me I'm gonna have 32. I guess I'll have to erase this now. I'm gonna have 32 total pieces, and this represents one of the 32. Okay, so that's just 4 problems to explore. And what I'm going to do is I'm going to take everything and just put it on one page, not the modeling and whatnot. Hopefully walking through the modeling was helpful.
Yeah.
But I'm actually going to write down like what we did in each problem on one page so we can make sense of that. So the first thing we did is and bear with me, we did 4 divided by 1/3, and that was equal to 12. Okay. And then after that, we did 8 divided by 1/4, and that was equal to 32. And then we did 1/3 divided by 4, and that was equal to 1/12. And then we did 1/4 divided by 8, and that was equal to 1/32. So again, like I said, I'm gonna write all these down so you can see them. I just wanted you to explore them again with us. Um, so let's see here. Oops, wrong thing. Okay, so we said 4 divided by 1/3 was equal to 12. And then we said that 8 divided by 1/4 equaled 32. And then on the flip side of it, over here, we said then 1/3 divided by 4 equals 1/12. And then over here, we said that 1/4 divided by 8 equals 1/32. 1/32. Okay, so this comes back to everything. So we just walk through all this. Let's think about the patterns. What do we notice? And this is where I'm gonna kind of sit here and babble a little bit. Whoa, pattern. So maybe I can just erase this. So let's look at those patterns. I want you to think about like, what do you see? Right? What do you see? What are some patterns you see? And hopefully you've connected on a few, and let's talk about what we see. One, for example, here, like in a sense, I wouldn't say these are the inverse, right? Because they're both division. But when we take a whole number and divide it by a third, we get 12. And when we get 1/3 and we divide it by 4, we get 1/12. So we can even see the pattern here. This is 12, this is 1/12. Started with a fraction, ended with a fraction, right? Here I have 8. And when I divide it by a fraction, 8, which is a whole number, I end up with 32. Now, again, let's just remember that technically I don't have a whole number. I don't have 32. I didn't get 32 wholes out of this, but I did have 32 pieces. But this is one thing to notice in that pattern is like, actually, if I start with a whole number and I divide by a fraction, my answer will actually be as a whole number, kind of, right? Just as a pattern to recognize. It's again, it's really not 32 wholes, it's 32 pieces that are 1/4. But it's another pattern to help you think about your reasonability when you do a problem. It's like, okay, if I'm starting with a whole number and I divide by a fraction, I should have an answer that is more whole numbers. When I start with a fraction and I divide by a whole number, I'm actually going to end up with a fraction. And then you could also argue, oh, I'm seeing some patterns, right? There's some other skills in here that is the inverse. Well, if I'm dividing with a whole number by a fraction, well, 4 times 3, that equals 12. That actually works, right? 8 times 4 is 32. That actually works. Same thing over here, same concept again, though, is 3 times 4 gets me 12. But again, I know it's a fraction, so it's 1/12. Or that 4 times 8 equals 32 as well, but it's a fraction, so it's 1/32. So again, we could really start to think about like what do we notice in some of these patterns when and this is really what I hope comes out of this, and then I'm gonna wrap this video up. When I start with a whole number and I divide by a fraction, we saw what occurs is we actually get a whole number as an answer. So a whole number divided by a fraction equals a whole number. We also noticed today as terms of a pattern is that when I have a fraction and I divide it by a whole number, I end up with a fraction as my answer. So that is just part of the reasonability to think about as we do this. So again, if I already think that going ahead and I say, oh, well, what's 8 divided by 1/3? Before I even do my math in my head, I can already say to myself, oh gosh, that means my answer will be a whole number. Or again, maybe you have 1/6 being divided by 5. Well, before you even do math, you're like, oh, well, I'm starting with a fraction, so my answer is going to be a fraction. So that's really the goal we're kind of looking about. So as you get into today's work, just like dive into that, think about this. It's really about like, uh, I wouldn't call it what am I trying to think? You're not really like rounding or estimating, you're just using reasonability, but that is so much of math. So really think about like how can I be reasonable going into these confusing problems, especially word problems. And that's why, like in the past 2 days, we've really studied word problems and said, when we have a word problem, let's figure out what the expression is so that we can make sense of the story. And then you can be more reasonable with your answer. And that way you won't end up, I don't know, cutting your friends up and feeding them to graham crackers because story actually has you cutting up graham crackers and feeding them to your friends, which is way, way more reasonable and legal. So please do not participate in any such actions. All right, cool. With that being said, that is us. We are done. Keep up the good work. Ask your questions. Questions are great. Knowledge is great. Keep exploring. Keep up the good work. Peace.